Hello, everyone. This is episode 57 of Get Your Tech on, our show on all things DOCSIS. I'm Brady Volp, founder of Nimble This and the Volp firm. With me today is John Downey, CMTS technical leader at Cisco Systems. So, John, how are you doing health-wise?
Good. No, no coughs, runs, drips, or errors. I think I'm fine. As
No,
fine
that
as
yeah, that's good to hear. In the Atlanta area here, there's lots of us who have coughs and drips and stuff like that, but it's mostly due to pollen. Of course, we do have COVID-19 going around, and I mean, I'm sad to say it's going to get worse than it gets better. But that brings us to the topic of today. We're going to be talking something that's hitting a lot of operators right now is with everyone staying at home. Well, not everyone. We have a lot of folks, on the front lines fighting COVID-19, but many of us are working at home. Many children are studying at home, and they're tying up a lot of the broadband networks, which is, sort of a unique thing that we have going on. As bad as COVID-19 is, and as much as it's hitting other people in the industries, it's in a way it's good for the cable industry, good for the telecommunications industry, because right now it's actually quite critical infrastructure for everyone. So a lot of us have been getting calls. Many cable operators are trying to do the best that they can to maintain the cable networks, or the broadband networks, as well as increase the capacity of the broadband networks from everyone working at home. Curious if you're also seeing the same thing.
Yeah, definitely. I'm getting calls and emails from people globally. I mean, it's not just in the U.S. really. In Latin America, I used to say they were probably behind the U.S. 4 to 5 years in capacity offerings because they didn't have Google Fiber to push them. They didn't have the competitive nature of someone coming in with higher speeds to push the industry. Could you imagine where we'd be at today with this virus and the quarantines going on if we didn't have DOCSIS 3.1 or if we didn't have DOCSIS 3.0 even? Because technically, a lot of the speeds we offer were because of marketing reasons or competitive pressure, not because the market was asking for higher speeds or not. I'm talking individual people. Like many people can't use 1 gigabit per second.
Yeah.
They wouldn't know how to use it, right? But they want it because their neighbor has it, or they want it because Google Fiber had it. So everybody wants what someone else has. And it's a good thing that I have to thank Google Fiber. They got in it to spur the industry, and it worked. It helped push DOCSIS 3.1 a lot faster than it took 2.0 and 3.0 to get ratified. So 3.1 has been implemented, and now I think we can reap some of the fruits of that labor. Now
Yeah,
we're going
no,
to have to. We're going to
yeah.
have to.
We've been doing a lot of work in the industry over the past few years to, just to your point, we're deploying 3.1, we're doing a lot of upgrades and stuff, and I think it's really fortunate we've been doing that, because now with all the people at home, we'd be in a much worse situation if we were sitting around with DOCSIS 2.0 networks, and even in many areas with just DOCSIS 3.0 networks. So it's really quite fortunate we have the infrastructure. However, we still have a lot of operators that are still struggling with it. So I do want to plug another vlog that I just listened to on Tuesday as I was preparing for this one, which is one that Z-Quorum does. They're partners with Nimble This, the other company that I have, and they do a lot of provisioning and stuff, but they do what they call Tech Tuesdays. And so Rick Usey did it on, he does this podcast, he did it on recommendations that cable operators should be doing in the midst of COVID-19. And I don't want to spoil everything, but he covered a couple of nice topics, like what the FCC is recommending cable operators to be doing during COVID-19. He covered a lot of the traffic numbers the cable operators are seeing, the traffic growth, since everyone's been sitting at home, working from home, students studying from home.
Watching more over-the-top TV.
Yeah, a lot of over-the-top
working, but
TV.
watching.
And he covered a lot of the statistics that we won't cover those today. Put up a number of graphs on how Wi-Fi traffic is growing, DOCSIS traffic is growing, and you heard many times it was like 90%, 90%. A lot of numbers, 90%. He had some operators talking about what they're seeing. It's not everywhere. Some places where in his podcast we're only seeing like 10% growth or something, but I think it's only going to continue to get worse as we go. And there was a lot more. So you can Google their Tech Tuesday podcast. If you Google just Z Quorum Tech Tuesday, I'll also put this in the in our chat that's going on live. So I put a link to their podcast, and I'm just recommending that if you're interested in this type of information, what's going on in the cable industry, there's a lot of good information that Rick put out, so you can watch their YouTube there, and then we don't have to cover all that information here. So before
I suspect that the Rural Broadband Initiative and this will highlight the not missteps, but the fact that we have a disparate broadband offering, right? Mm-hmm. The people that are in small rural areas, I'm happy that I have fiber connection now.
You were one of those people just until.
I know, just up to about a year ago. Will suffer the most. I mean, because a lot of people can go almost business as usual. I'm working from home, but I'm doing everything on the computer, everything on the internet. I'm not really missing too many steps in that regard. But there's a lot of people that might go home and not have high-speed access or high enough speed access. So they're trying to do everything over either their mobile phones, and they don't have 5G, right? So maybe this actually pushes 5G faster as well. But I think there's a disparity across rural and urban areas where you might have access to multiple vendors, suppliers, mobile access, hotspots, you name it.
Yeah, so I mean, to that point, I talked to another colleague of mine, and he said he was sitting in his empty office building. I asked him why was he going into the office, and he said his only internet connection at home was his phone tethered to his computer. So he was just going to the office to use the internet. And speaking with someone else, just as this was getting started, the whole with everyone working at home and school children, doing homeschooling, one of his comments was he wouldn't be surprised if this, if sort of broadband didn't turn into some sort of critical infrastructure, if it didn't fall into something like that after this is all said and done. Hopefully sooner than not later, but. So
with that said, we have to be careful, right?
Oh yes.
Because if it becomes a utility,
that is exactly what he was saying.
then it becomes more controlled by the government instead of an open access and everything else.
Well, that was exactly the concern that he was saying. I mean, he wasn't saying it was necessarily a good thing. It's a critical infrastructure, but right now, it really kind of is critical infrastructure. I mean, I want to thank all the techs out there that are keeping our networks up and running. The cable operators are keeping the cable networks up and running, but it definitely is critical infrastructure for us today, even though it's not really deemed so. It's very, very important for us. Our chat room, Dari Marcia said the other things missing is for most is a dedicated office space other than the kids' room. So yeah, I mean, I've seen a lot of if you've seen anything on some of the Instagram pictures and stuff like that come up as the makeshift office spaces that people are setting up. So it's on clothes baskets and stuff like that because there are a lot of people who aren't accustomed to working at home like you and I. You don't have someplace dedicated set up.
You don't have a quiet space.
Yeah, exactly.
You need a panic room. And a quiet space.
Yeah, to get away from kids and noise and everything like that. So, So one other thing in the news before we get started. So I guess 10G capability. There's an article out. 10G capability for cable broadband inches closer. So we're the DOCSIS 4 specification is getting closer to being published. That is, all good news, particularly now as DOCSIS 4 is going to be really important for us. I think now more than ever moving forward because I think the world after this is going to change.
Yes.
I think this is for every company. This will be a standard thing where every company is going to prepare to have all of their workforce working from home or have a contingency plan to expect that. I think we're going to be working from home for a long time, but I think a lot of companies were not prepared for this. They didn't have the VPN connections prepared for this, and still, I know, like I was talking to my local bank, they have their lobbies closed, but they're not capable of working from home, and those things have to change, and that will, we need the broadband infrastructure to be able to support even the additional people that can't work home from today, which that is the main topic of discussion today. I know. So as the Volp firm, the consulting that we do, business has actually been quite heavy lately because we're working with a lot of cable operators to help them figure out what they do right now under the load when they went from daytime loads of being 10-20% utilization to now being 100% utilization. So those are big challenges for a lot of operators, especially when we have part shortages right now. We can't get equipment, we can't get components easily, we can't even get support a lot of times because those people just aren't in the office. So I want to start off and see, I think we can probably start at the physical layer and say, what would be the first things that we would start doing to alleviate the bandwidth congestion that we have right now?
I think that's a good way to categorize this. Would be the 7-layer model, the 7-layer model, OSI model. And I wanted to say that this is not the first virus we've had, and it won't be the last. Yes. So, even when we get through this one and people go back to work, I believe you're right. A lot of people might say, I've already invested and put my time into setting up a home office. My employer is okay with it. Maybe I can go to a 3-day week, maybe not straight up all the time, but I think it alleviates congestion on the roads. That's one good thing about Atlanta, right?
Oh my!
Hopefully you're.
Oh my! It is so different. you can go to the doctor's office in 1/10 of the time that it would take you to drive there previously. I hope I don't have to go to the doctor's office.
And that's usually where you pick up the flu, is at the doctor's office.
Exactly.
So, looking at this from a layer 1 first, I think is a perfect idea. Once you exhaust any type of physical layer segmentation, which we assume we can't do that on the fly anyway, it would take too long to do, and it pushes people outside to actually do it. And you have to buy the hardware. Maybe you don't have the hardware. Maybe you can do an upstream split, because maybe a 1x1 node is really a 1x2 node. Maybe it's doing baseband digital reverse or enhanced digital reverse, the EDR. So you can do 2 upstreams. So you can segment the upstream without segmenting the downstream. You can segment the upstream and then just add more upstream channels to that other upstream fiber node. It's fiber node configuration on CMTS. It's still the same physical fiber node, but it looks like 2 upstream fiber nodes. Mm-hmm. So you might be able to do that type of segmentation and add more channels. So it might be a licensing issue with the CMTS. I'll go down that path in a little bit.
Well, let's just stop right there for a second, because I think it's important for people to understand why maybe they would look at a digital return versus an analog return. And I was just talking to a customer this morning about this, who they're doing just that. So they have just a single node. It's not segmented. Now they're looking to segmenting that node. And, one of the challenges they have is now they don't have enough optical power coming back to the head end with the traditional analog returns. So they are looking at the digital return in order to compensate for that. And I think that's why you're talking about the EDR, which is a Cisco product, but other vendors have digital returns and stuff like that. So they needed 3 dBm of optical power to hit the return path receiver in the head end, but they're about -7 dBm at that optical return path receiver. And so this is in the analog world. Yeah. So to your point, you're suggesting maybe we look at a digital laser, and this, if you have them, if you're able to get inventory of them, and this gives you a little bit more dynamic or flexibility to have a little less optical power in the return when you're starting to segment the nodes. Is that sort of what your line of thought was there?
Yeah. I mean, this technology has been 10, 15 years old, right?
Yeah.
Digitizing the upstream so that you have no laser clipping If you're not doing intensity modulation, which is an analog laser, you have no laser clipping. It's on, off, on, off.
Mm-hmm.
You can still have like an A to D type of clipping because you have to digitize that analog signal coming in, and you're digitizing ingress and everything else. But the BDR technology, baseband digital reverse, was really to 5 to 42 megahertz, which was simple to do because it's limited spectrum, right? 5 to 42. When you went to 85 megahertz, now because of Nyquist sampling and the number of bits per sample and how much speed I needed on the digital link to do 85 megahertz, we had to do EDR, enhanced digital reverse. So it made the digital link a little bit faster. And I promoted this 20 years ago. I said, if we're already doing analog to digital to analog to digital to analog to digital, we're doing all this up, down, up, down, up, down conversions. Why not just get rid of the analog link altogether and just put the Broadcom chipset right inside the node? Hence Remote PHY. And we never did it because we did it. We separated the upstream and downstream from the CMTS, but we did the downstream first. We call it modular CMTS. And I said, well, if we could do that, why can't we do the upstream? And I always wanted the upstream in the node for upstream laser clipping, noise. I'm an RF guy, so I was always worried about upstream noise. I talked about ingress cancellation and all the stuff we could do with the Broadcom chipset and all that stuff. And I said, well, it never came to fruition to upstream and downstream were still tagged together because of scheduling and timing. And that's when Remote PHY came out. So I said, all right, well, I already did modular downstream, so let's do modular upstream and downstream and move it out to the field. So I will always evangelize about the distributed access architectures and doing digital fiber. Get rid of the analog fiber. But today, it's probably too late for these people or customers that don't have that capability or the flexibility to do that. So like we just talked about the digital reverse, do they have a fiber node that will even take a digital reverse module that plugs into their existing housing? Probably not. I don't know that they do. I'm just assuming when I was going down that path of segmentation on the upstream that they already had a digital reverse, still an analog laser, but it's the digital reverse and an analog laser or analog upstream, downstream. Actually, analog downstream, it would be a digital baseband digital reverse upstream. But I'm assuming that they did not use it to its full advantage. Meaning, when you buy that module, it could be a 1x2. So it's sending back two separate RF. It's digitizing two RF legs, combining it in the time domain, sending it back on a digital link, and it feeds the optical receiver head end that splits off two RF ports.
Right.
So for the case of an RF guy, that's two upstreams, two separate upstreams. If it's two separate upstreams, you can assign the same upstream frequencies to both those separate upstreams. There's no overlap because you actually combined it in the time domain on a digital link. So there's no overlap.
You split the subscriber count now on those upstreams.
Exactly. Easy, right? Easy peasy. Yeah. So you split, and I'm saying that would be your first step. So that's physical layer, right?
And you can do the same on a downstream. Because you can you can segment the downstream, and you can split the subscriber count on the downstream and duplicate the frequencies on those different downstreams on the ports of the fiber node.
I remember even Cisco had a fiber node that was 4x4. So you could just put more transmitters, receivers in the housing itself. The housing is huge, right? But you could put in more transmitters, receivers, and physically segment the four legs of the RF node. Yep. So they could all be separate segments. So you could have one big service group, or you could have four service groups from one fiber node physical location.
Yeah, and I think a lot of the nodes, fiber nodes out there, can be, depending on how you bought them already. The housings can be 4x4 segmented. Typically, the modules themselves may not be 4x4 segmented, depending on how you bought that module that goes into the housing itself. And I think, I know talking to a lot of different operators I'm working with now, first they're going and seeing, does the vendor have any of those 4x4 segmentable or even 2x segmentable modules in stock, or if they already have it, maybe they need some of the parts or extra transmitters and receivers. So they're looking at the vendors to see if they can get those parts. Next, they go to the secondary market. So there's a lot of secondary vendors out there that have refurbished equipment. So that's another opportunity. And then the next thing they're doing, and I really, I hope operators are collaborating with each other. I know the smaller operators are starting to do this, and also maybe the larger operators this is really the time to, with everything that's going on, we got to start sharing inventory. So if you have a really really hope that operators are doing that with each other. If you got a warehouse of excess inventory, now's definitely the time to start sharing it around. And then we look at things like the barter system. There's a lot of things we can start bartering now, and this is definitely the time to do that in order to
I
maintain
mean,
our network and
think of
infrastructure.
anyone that has started to transition into DAA, remote PHY or
Yep.
remote backFi, any of that. I hate to say that you don't want to be a hoarder, but
Yeah.
if you saved all that analog stuff you ripped out, you could probably sell it or use it or donate it and probably write it off for taxes or whatever. Someone could probably find usage for it. There's a lot of systems out there that could benefit from the older technology. I'm always going to push for the newer technology, but we live in the real world, right? So if you have network out there that's analog network, which most people do, you might be able to benefit from stuff that customers ripped out of their network to upgrade to the newer technology.
Yeah. So
Even modems, right?
yeah, so to any operator out there who you're sitting on a warehouse of inventory that you're probably not going to use, this would be a fantastic time to contact a secondary reseller and dump it to them, because there's a lot of operators that are looking for equipment. I know I talked to one this morning that they would love to have, transmitters, receivers, stuff like that to do upgrades, nodes to do upgrades, to split nodes and stuff. They need to do this right away. Get it out there to the secondary vendors, or if you have cable operators, small operators around you that are doing upgrades, other operators, reach out to them, or small operators reach out to the larger operators that, as John said, has done these DAA upgrades and are probably sitting on a bunch of stuff that they just haven't got around to getting rid of. That start spreading the love, get that stuff out in the market.
Yeah, you could have a lot of goodwill with this.
Yep.
So with that physical layer, I will never disregard the fact that you just might not be running optimally because of physical layer problems. You could say, I have capacity, but it looks full. But what if 25% of it is from drop packets?
Yes.
What if it's denial of service? Like, it could be physical layer is a problem. So always look for uncorrectable FEC.
Yeah, so I think we can break this. We can break this up into two problems, because I know where you're going to go with the traffic on the network we don't need, and
Yes.
then there's the traffic that's getting dropped because our network's impaired. So let's start there, because that's there's lots of opportunity, I think, to optimize the CMTS to fix impairments, so we're optimally passing that traffic through. And now we're getting into correctables and uncorrectables that we really need people, I think, to really focus on those today to optimize our network.
Yeah, I would say I would focus on uncorrectable, right? MER, SNR, CNR, correctable are all a means to help troubleshoot. Uncorrectable is the bottom line to your customer. If you're dropping packets, then it's even worse on your throughput, because a lot of the applications have to resend.
Mm-hmm.
So not only are you just dropping that, but you're actually still resending the other stuff. So it's a bad either way you look at it. So making sure that the plan is clean, I'm not dropping packets. So that would address the traffic that is not traffic at all.
Well, it is traffic. It's just traffic that dies and then has to be retransmitted.
Yeah, exactly. So then if I can alleviate that, then I don't have to retransmit. So that's like twofold. The other part is, what about traffic that shouldn't be there? Yeah. What about denial of service attack, or someone's being nefarious? Nefarious,
I think. Nefarious.
Fair, whatever. 220, 221.
So that's a really good point. And so that comes into
generating traffic shouldn't be there, right?
Yep. And so I did this recently myself on my office network. So I've talked about pfSense and previously, how it's really nice router. There's some applications you can put on there that filter all the ads, any bad traffic you don't want coming into the network. And I constantly monitor. I saw a reduction of 40% of traffic into my office network just by blocking crap that shouldn't have been coming in. So I think this is kind of analogous to what you can do on a DOCSIS network, either the DOCSIS engineer by putting ACLs, access control lists, to make sure you're blocking traffic that shouldn't be on there, whether it's denial of service traffic, whether it's probing traffic, anything like that. Now's the time where we want to tighten up the CMTS as much as possible to keep that stuff off. Or it can also be done at the edge of the network with routers. So I would say, John, that's a really good point on your part. Both uncorrectables. We want to make sure we're not retransmitting packets, and then just spending a lot of time filtering anything off the network we don't want to have. We can really see whether that's 5, 10, 15% of traffic we want to get off of there. That's a substantial gain when you're already at maximum utilization.
I agree. We even have things that like ARP filters when we had problems with ARP a long time ago, where the old Linksys home routers, when they first came out, they were ARPing everything on a cable network. So we came up with ARP filters. So that helps, alleviate the congestion of control traffic type of stuff and ARPing. I just had a thought on that as well. So one of the apps that we're seeing generating more upstream traffic is the Ring doorbell, because the Ring doorbell is motion sensing and it uploads to the cloud. So think about this. I just thought about this is if I'm working from home, there's no need for me to access it remotely because I'm not at work accessing it. So I would almost think that the cable operators should put out a notice to say, hey, you're all working from home. Please either figure out how to set up your Ring doorbell that if it's motion, it stays within your own network, or can I block it? Because why do I really need to upload it if I'm at home anyway? I'm just thinking
Well,
out loud here.
the problem I see with this is a lot of local police stations are tying into Ring doorbells, and I know that's
Okay.
happening in my area, and they are, whether you like it or not, they're constantly monitoring, or they want to be able to access that data and that traffic anytime they want, that video traffic. So it's always, Ring's always
Yeah.
streaming it up to their servers, so law enforcement can get access to it should there be some sort of, accident or break-in
Yeah.
or something
Yeah.
like that in the area.
Yeah. I'm just thinking out loud, how do we alleviate some of the traffic on the upstream? And this is why we go down the path of DOCSIS 3.1 and DOCSIS 4.0. You mentioned DOCSIS 4.0. Extended spectrum DOCSIS isn't really just to extend downstream. It was to extend downstream because the upstream needs extended and it's going to eat into my downstream.
Yeah.
Hence, I got to move everything up. So the whole idea is we need more upstream. We need more upstream spectrum. We need to make it more efficient by utilizing DOCSIS 3.1. We got to keep it clean and have the higher modulation that's available. And the only way to do that might be remote PHY, digital fiber, so I can do higher modulation schemes. And then once I go through the attrition of DOCSIS 2.0 and 3.0 modems, I can start rob Peter to pay Paul, get rid of the single carrier qualms and start expanding the OFDM and OFDMA. I talked to my manager earlier today, and he even said, we talk about robbing Peter to pay Paul, and I was just thinking in the DOCSIS realm. What if you could make a case for not as many people are watching certain video channels, more people doing over the top video? Well, I need more speed capacity. So can I expand my OFDM and DOCSIS 3.0 single carrier qualms by alleviating some spectrum from getting rid of some video channels?
Yes.
That one might be a hard sell, but in a case like this, maybe it's not as hard to sell.
Right.
If you can't get blood from a stone. You got a spectrum. It's a limited amount of spectrum. It's a hot commodity. You can't do node splits because it's just not physically possible or economically possible. What can I do today? What can I do with the spectrum I have? Can I just activate more spectrum? We're even kicking around the idea we have this idea of all you can eat license. We have one vendor or customer in Canada doing the IBU, Infinite Broadband Unleashed, where we say, do whatever you want with the CMTS. It's all on, and we monitor your WAN traffic and how many subs you have, and you pay for that based on some formulas.
Right.
So instead of paying for a license for Spectrum and stuff like that, we're like, you know what? All you can eat. Turn it all on. That way, if no one signs up, no harm, no foul.
Yeah.
You're not paying for it because there's no traffic. But if someone signs up and there's traffic on your WAN, then we use a formula to figure out what your cost is per sub or whatever it happens to be. I don't know all the details around it, but that's a case where you could offer really high peak speeds by turning on everything and say, go at it. You're still limiting customers to the speed they buy, but you could offer the higher peak speed without having to pay for something that no one uses.
Yep.
Yeah.
So in terms of what we could do now, what do you think the benefit of converting, say, primary downstream channels to secondary downstream channels? What would that offer in terms of just additional bandwidth?
So right now, let's go back to the case of changing your 1x1 architecture to a 1x2 fiber node.
Mhm.
If you made two fiber nodes from one physical fiber node, two upstream segments, and you put four upstream channels on each, well, now your MAC domain, your service group, is 8 upstream channels. Four upstreams on one, four upstreams on the other. Every one of those upstreams creates map messages on the primary downstream. I used to calculate about 0.25 megabit per second of overhead for every upstream because we have map messages on the downstream every 2 milliseconds and they're certain size and they're replicated for every upstream. So every upstream has its own set of map messages. Well, I'm finding that it's actually closer to zero point 0.4. So 0.4 times 8 upstreams is 3.2 megabits per second of downstream overhead.
For each primary downstream.
Each primary downstream. So if you have 24 downstreams and they're all primary, take 24 times 3, you just ate up 72 megabits per second just to support the map messages for all
Right.
those upstreams.
So now if we
So,
go ahead.
so you're better off. The only reason why to have primary downstreams is if you have a lot of DOCSIS 2.0 modems.
Right.
You don't have a lot of DOCSIS 2.0 modems, then just do every other downstream or every fourth downstream as a primary. And by staggering your primaries, you get better representation of the spectrum across there because your primaries will still load balance 2.0 modems across. The 3.0 modems will distribute their primary they use because they do bonding groups. So they'll use any channels that are in their bonding group, but they lock on one as a primary.
Right.
So we even have a feature where when the 3.0 modems come online, they don't all use the same primary. We want to make sure that if 12 modems lock onto a 24 channel bonding group and there's only 4 primaries, we make sure those 10 modems are kind of load balanced across the primaries. Even though they're bonding all 24, we don't really care, but I still don't want all of them using the same primary because once you lose the primary, modems go offline.
And how much money does that cost?
It's free.
It's free. That's right. So you gain capacity.
I got a deal for you. For you today, you call in right now.
$9.99.
I think about that too. It's like we talk about physical segmentation, make sure there's no physical problems, controlling abusers, and then I think, all right, what about what I have today? What could I do? I could maybe activate more spectrum, or how do I make the spectrum I have more efficient? Then we get into make sure load balance is correct, modems aren't in partial mode, making sure the utilization is relatively stable. I get a little bit worried about that because when customers say, I want to see utilization 50%, 50%, 50%, 50%, I'm like, how often are you updating those utilization numbers? A 50-50 might not be 50-50 anyway. It could be 100 and the other one's at 0, and then 2 seconds later it's 0 and 100. But when you average it out, it's 50 and 50. You know, what's your rolling time window? You know, so I don't try to balance things perfectly. I'll give you another example is if I have an upstream channel at 60%, another upstream channel at 20%, is there really a concern there? The 60% isn't really congested. No one's suffering. So why would I make a case to move a modem from one interface to another just to make the numbers look equal? That just gives me a warm and fuzzy, but it doesn't do any good because anytime you move a modem, you run the chance of causing problems. And what if you move a modem that then happens to do a lot of traffic? Now all of a sudden it's off balance the other way. So it's
and to your point, the modem or the problems you're going to cause when you're moving modems is you could actually cause that modem to go offline, or some modems don't load balance as well. I've also seen the load balancing configuration in CMTS is done wrong so many times. So I think it's I always strongly recommend to everyone to have some type of SNMP monitoring system that is actually showing you what all your downstream channels look like, the utilization of all your downstream channels, the utilization of all your upstream channels, and showing the history of that. So you can tell, is one or more of my downstreams always being really heavily used while the other of my downstreams are seeing very little utilization. And by heavily used, John, I'm talking well more than 60%. It's your downstreams, heavily used downstream is 80% or higher. that's
Agreed.
that's heavily used, and you don't want to see one or more of your downstream sitting at 80 or 90%, and while other your downstream channels are sitting at 15 or 20%. That is a very unbalanced downstream load balance system.
And even that right there, what you said, utilization can be taken different ways. How did you do the math to convert a utilization? Did you work? Because you might be assuming, because you work in this field, you look at MIBs, you look at S&P, you know what you're grabbing. You're actually grabbing Cable Labs MIB that is a utilization was thought about by a lot of people to be correct.
Right.
I had systems that used to just grab the bits per second that was transmitting in a certain time window and divide it by 42.88 megabits per second. I'm like, wait a minute, your denominator is the raw rate of the channel.
Yeah, that's not going to work out right.
I mean, the usable rate of a downstream primary channel is close to 36.5. Yeah. The usable rate of actually maybe 36. Let's say 36. The usable rate of a secondary downstream channel, no primary, no maps and stuff like that, is about 37.5. So if I were to take bits per second of actual traffic over a sliding time window, I would divide by that denominator, not 42. And even that is an assumption. 36 megabits per second is assuming that you're actually transmitting a lot of big packets on the downstream. When you do a lot of smaller packets like voice packets, there's more overhead. So that pipe is only worth about 35 megabits per second. Right. So my point is, utilization reporting by trying to do your own math can be a little fuzzy. Yeah. So we got to make sure we know what we're looking at, how quickly the time window we're averaging, and is it realistic, right? Absolutely. And we don't want to scream the sky is falling, the Chicken Little syndrome. We don't want to say, it's 80%. Yeah, it was at 80% for one time during the day, and it was just a spike or something. I don't want to move stuff just because the numbers didn't match up for 1 second.
But again, just like we talked about secondary versus primary channels, getting load balancing right on the CMTS can alleviate utilization. Cost for that?
Yeah, back to you.
Free.
Go back to the tape. Go back to the tape. Yeah, so,
$9.99.
Yeah, the cost for that is free. Zero, zilch, nada. Yet. No. Right, so, load balance. I have a whole presentation on that as well, on best practices for load balancing, and I will always lean towards keep it simple, stupid solution. I don't know if the other S stands for stupid or solution, so keep it simple and stupid. Kiss the principle. I like to keep it simple. But there are a lot of little things like when a modem moves between two bonding groups, the default technique might have been, or even for DCC, technique was technique 1 or 0. Technique 0 reboot, so the modem would reboot, and that's not good. So there's different techniques. There's a lot of things to help the modem stay online. Even in our Cisco load balancer 3.0 modems, we were smart enough now to say, put modems into a candidate list of throughput that's happening right now. So if I move a modem from a 20% utilization or a 70% utilization virtual channel, if you will, 8 channels, to a different 8-channel bonding group that's at 20%. But what if that modem's doing 300 megabits per second?
Yeah.
If he moves over, it's just going to change the other way. And he's going to move back and forth.
Everyone's going to go to the other screen.
It's thrashing. It's like I call thrashing, right? Back and forth. Yep. So we put modems into a candidate list because the ultimate goal is to move one modem with enough speed to balance the utilization. So we can do that. And I'm like, that's perfect. That works well. Yeah. I don't want to move 3, 4, 5 different modems just to have the utilization change. And then 2 seconds later, it changes back the other way. And it just causes more headaches. Which brings up another point you talk about load balancing is, what if I set up my load balancing and the utilization is off and there's still no load balancing happening? We don't move modems that are in partial mode. So what if a modem is in, if a modem is in partial mode, it does not participate in load balancing. So modems that are doing full W online, 8-channel bonding, they only move to like bonding groups as well. So if you have one 8-channel bonding group, it has nowhere to load balance anyway. Yeah. It's only one group. So when you make bonding groups, those are like virtual channels now. So we'll load balance 4-channel to 4-channel to 4-channel, or 16 to 16, but we won't take an 8-channel and move it to a subset of a 16. You have to physically or manually make multiple 8-channel bonding groups.
Yeah. And so when you talk about partial mode, just as a reminder for everyone, a partial mode modem is a modem that should be locked to, a certain number of downstream or upstream channels, but it's not able to lock to all the downstream or upstream channels that it should be locked to. So that's a modem
Correct.
that's in partial mode.
And it locked on it. It registered properly, came W online, and then later on it might have sent a CM status message on the. So the downstream got a problem. The CM status message on the upstream talks back to the CMTS, says, "Hey, downstream 3 is having issues."
Yeah.
So now that modem goes
to
partial mode.
So we got a couple questions here, John. I'm just going to switch over to this, so because I know a couple of them look like they're specific to you. So hey, Brian Wilson, thanks for coming back once again to watch us. Good to see you. Dari, I think we got yours, and you talked about eliminating a link in the analog, so to DAA, so you can see this happening, the local looping replaced by 5G virtual drops from RPD and RMDs. But I think that, Dari, I think that's going to be longer term than the immediate, so, and that's going to cost some money.
Yes,
that is not free.
Is that a question, a comment? Or...
I think that's just a statement from Dari.
Yes.
So Miro says, how to mitigate higher utilization on the first upstream channel of upstream bonding group with 4 upstream channels on a CBR8. Any comments on that, John?
Oh, yeah. Perfect question, because I almost forgot about it. And it's not on by default. Under the cable interface, there's a command called cable upstream balance -scheduling or scheduler. Might be scheduling, but you can always tab it out and figure it out. Cable upstream balance scheduling. When we first started doing upstream bonding, the CMTS would schedule mini slots left to right, meaning the first upstream in the bonding group and then to the other ones. And you would notice that the utilization on the first upstream would always be higher. It would always be like a stair step. You could be at 80%, 40%, 20%, 20%. So we implemented a command called cable upstream balance scheduling, so that when a modem, say, asks for 100 mini slots, we would say, all right, well, we'll just evenly distribute it across the 4 upstreams. You could make a case for the other way as well, meaning why not let the CMTS schedule as much as it wants on the first upstream, and then the second and the third and the fourth? If it's not hurting anything, if it's not cutting, because the CMTS will then see the next modem ask for many slots. It'll see upstream 0 is kind of higher utilization from the first modem. It would just schedule an upstream 1, 2, 3, and 0. Do you understand? Like the CMTS will schedule where it needs to schedule without creating congestion. So some people could make the case and say, I actually like that better, because when a modem's doing single channel speed, by keeping a lot more traffic under one upstream, you have one request grant cycle.
Right.
And you're not going across multiple upstreams, or maybe not introducing any type of jitter or delay. But when you're looking at upstream utilization on graphs, you want it to see it nice and equal. And I could also make the other cases, if you do allow it to schedule all from the left to the right, meaning upstream 0 is more, then DOCSIS 3.0 bonding, upstream bonding, could interfere with DOCSIS 2.0 load balance.
Yeah.
Because now more 2.0 modems are going to have to move to upstream 3, 2, and 1, because upstream 0 looks like it's full all the time because of all the DOCSIS 3.0 traffic.
Right. Okay.
So the answer to that was there is a fix for it.
There is
cable
a fix.
Upstream balance schedule. Put it under the cable interface.
All right, perfect. Next one is from Ron Jones. He says, all-you-can-eat licensing, which you mentioned earlier. So if the infrastructure is in place, the ISP can offer a sub 1 gig and only have to pay for the license of the service group, avoiding full card chassis license cost. So, understand that one? You got it?
I'm trying to read your small print. Say it again, because what is the actual question? If he can...
In all-you-can-eat licensing,
Yeah.
so if the infrastructure is in place, the ISP can offer a sub 1 gig and only have to pay for the license of the service group, avoiding full card chassis license cost. So you don't have to license a whole chassis and a card. You can just say I'm going to offer sub 1 gig and for just one service group.
No, I would say it's even better than that because
Maybe it's semantics. I don't know how I'm reading that. I would say it's even better than that. Let me give you an example. You want to offer 1 gig service across your entire footprint, but you don't know who's going to sign up. So instead of forcing you to pay for a license for every single service group, you basically are only going to pay for the number of subs and the WAN traffic. It's not even the number of subs that have 1 gig service. I think it might be just total numbers. I don't know all the specifics behind how the formula is created, but the point was, if you want to offer higher peak rates, you have to turn on more spectrum. And if you have to turn on more spectrum everywhere ubiquitously, and you don't know who's going to sign up, that's very cost prohibitive.
Right.
So you have this all you can eat where you can say, turn it all on, and I'm only paying for actual subs on the box and actual WAN traffic. So if there's only one DOCSIS 3.1 modem out there that signs up for the 1 gig service, it's kind of like no harm, no foul. Because one, he's not generating that much traffic, so there's not much extra WAN traffic anyway.
Okay. All right. Well, free marketing to you. I'll send you the invoice after the podcast. So let's see. They got a little bit more time here. Anything else?
So let's step back. We need to recalibrate. So you said we started this with layer 1.
Yeah.
Right. So we hit physical layer. Layer 2 is Ethernet.
Mm-hmm. Which we talked about. We talked about making sure that your uncorrectables are fixed. You're blocking, putting ACLs in place to keep bad traffic off your network. Yeah. That's going to help increase your capacity. Load balancing. Primary, secondaries. That's going to get you more traffic.
We hate to say DPI, deep packet inspection, but you could use deep packet inspection to find out the type of traffic you have
and what you want to filter.
Yeah, and then we've taken that a step further where you could do STM, subscriber traffic management, where we do byte counting. And you can say anyone that goes over a terabyte within 2 days, we drop their speeds down. So you could, everyone signs some type of agreement that they won't be a service provider. Well, right. If you're offering 1 gig service to your customer, they become a service provider to their neighbor, to all their neighbors. So they generate a lot of traffic, and you can control that by doing byte counting. And by doing byte counting, it's not, it's the least common denominator, right? You're not looking at BitTorrent. You're not looking at certain applications. So you're not being biased, I guess, across traffic, because you can get in trouble for that type of stuff. So I would say deep packet inspection is good, at least to give you an idea what's going on. You could do byte counting and control abusers. You could try to use ACLs and block certain traffic. I've had some modems that are actually stealing service. So we have BPI Plus, we have cloning, we can track cloning. We have something on the cable interface or the CMTS called hot list, where if you do find a MAC address on one CMTS showing up on another CMTS, well, you could hot list that modem so it doesn't even come online.
Yeah, those are a couple good suggestions, John. If you're running BPI Plus yet, this is a really good time to start running it, because you're probably gonna see some modems disappear that you didn't have on there before. Cable theft.
Yeah, no kidding. Yeah. Yeah, and I worry that the more we rely, you say this is probably going to become a necessity, having home working and more internet access.
Security.
More people more people come out of the woodwork. Oh, now I have more people I can affect.
Yep.
Not only a physical virus, but now I have computer viruses and everything else.
So I think security is going to become even more critical as we as this becomes critical infrastructure for us. Security is going to become really, really, really important.
So layer 1, layer 2 is Ethernet. The only way to make Ethernet more efficient would make sure all your packets are 15, 18 byte Ethernet frames instead of small frames, but there's not much you can do about on the Ethernet side. Layer 3, IP. If you don't have to run a VPN, then there would be less overhead, but most people want to run a VPN for security. So you're in encapsulation, right?
I rarely do not run a VPN, so that's always going to be happening.
Yeah, sometimes I think I'd have better home connection if I didn't have to have my VPN. Don't do over Wi-Fi because there's extra encapsulation with Wi-Fi. So I try to eliminate all my variables to get the best speed and best latency possible.
Yeah.
So layer 3, layer 4, 5, 6, 4 is TCP or UDP. So on that front, TCP is used as a basis for adaptive bitrate over the top video. So the more video you have and you're streaming and saving it for DVR and everything else on multiple laptops and everything else, the more upstream acknowledgements you're creating more upstream traffic. Mm-hmm. Even though most new modems have ACK suppression, I found it doesn't seem to kick in very much for low speed downstream flows. So even though you might have 100 megabits of total traffic on your modem, that might be 7 different 12 megabit flows.
Yeah.
You understand what I'm saying? Because they're 10, 12 meg on the downstream is not fast, not in regards to ACK suppression on the upstream. So that could be one of the concerns is more ACKs on the upstream. That's layer 4, right? TCP or UDP. Not much we're going to do about that. The application is what it is. 5, 6, and 7. Now you're getting into HTML and
yeah, but actually, there is a good recommendation that I have in this area. I know a lot of the large MSOs will already have caching servers in place for things like Netflix, Google, all the large services. But I mean, if you don't, you should be talking to these providers. Definitely, if you're a smaller operator, you should be talking to these providers if you don't have a caching service. Depending on where you're located and the amount of traffic, you may be eligible to get either a free or a cost reduced or some type of caching server from a lot of the over-the-top video providers that you will put in your head end. And that will, it helps like Netflix, Google, stuff like that, because it's helping their data centers, and it's also going to help your data center or your network, because a lot of those movies, Google searches, stuff like that now start become cached locally in your network. It also helps the amount of traffic that you're pulling over your fiber link down to your network. So I'd say that's also an opportunity.
When does it know to update what was cached?
I have no idea, John. But they have all that stuff figured out, and I have a number of operators that I work with that have gotten these caching services.
I bet you we can make some analogies between this crunch we're having with internet access with electrical grid congestion. Yeah. Where they, what they've learned in the past and historically, we could probably learn from it. And some places have gone to, we have a different cost on your meter if you do certain things at different times.
Yeah.
So maybe we go down that path at some time, right? Like if I know you're going to do some DVRing, why not set it up to DVR this stuff in the middle of the night when it's lower capacity? And I will give you some kickback tokens or something. Yeah. Something to like a kickback.
So Rick Yinger says that for Netflix, they now require 8 gigabits per second in order to get one of their caching servers for anyone who's interested who's looking for those. So you can measure traffic and kind of estimate. But I would, a lot of things and he says the cache update is between 12 a.m. and 12 p.m. from what he was told. So to answer your question there, 12 a.m. to 12 p.m.
That's it. That's a whole half a day. That seems like a lot, right? Yeah.
I don't know how. Yeah. So anyhow, I think for the upper layers, that is something that could really help your network. And I would hit everyone that is an over-the-top service provider to see if they're offering this, because I wouldn't be surprised with the way things are changing traffic-wise, if that doesn't become something more prevalent that these providers start to offer. So I think that covers all layers of the OSI.
Yeah, I think you're right.
And what we can do.
If you look at, we already talked about the CMTS trying to make it more efficient, optimizing DOCSIS 3.1, maybe converting more 3.0 into 3.1 spectrum if you can. But that also comes down to how many 3.1 modems could take advantage of it. Load balancing, obviously.
Yep.
I'm trying to think any other. I'm sure I'll come up with a list.
So a lot of operators I've been talking to, and I think this came from the Zikorum podcast I heard on Tuesday, are now stopping going into subscribers' homes They're also starting to provision modems and just drop them off at the door. So this leads me into just, one more recommendation is software. Software gives you the ability to gain visibility into what's happening in subscribers' homes. So we talked about full band capture modems before. You can see all RF signals. You can see suckouts, tilt, roll off, anything that's happening into subscribers' homes. So that falls into the realm of proactive network maintenance software, SMP monitoring software. So, plug for myself here, Nimble this. We have a great suite that gives you a lot of visibility in that. You can do it all from your mobile app or a web interface. Definitely have SMP monitoring software in there to do that. So there's a lot that you can do to give you visibility into what's happening into a subscriber's home from an impairment standpoint, a signal standpoint with software. If you've not really invested or investigated that, and you can get this software installed in your head end remotely. You don't even have to have someone on site to install it, as long as you have some virtual machines up and running, or we can do it from the cloud. So those are other options that you want to think about doing, and those are things that can happen right away.
The tech would what? Go to the ground block, provision it, get it set up.
Put the modem at the customers in front of the customer's door, have them go in, install it, and then they can still stay on the outside of the house, scan that modem based on its MAC address and tell whether or not it's performing well or it's not performing well. And about 70 or 75% of the time, if a modem's not working, it's going to be the drop, the ground block, the tap, or outside plant issues. It's only 25% of the time that's in-home wiring issues, and at that case, it's really drilling a hole and feeding a cable from the ground block to the customer and say, plug it into this cable. So if we want to get a customer online, there's ways we can do it without entering the house.
Well, you think about also a lot of the cable modems are all Wi-Fi, so there's probably no need to go through the entire home cabling network, if you will. If you could just provide it on the other side of the wall, and they just plug it in and do Wi-Fi from there.
Yeah.
But I'm going to give you a case in point is, what if I hook it up, I provision it, it works fine, I give it to the customer, I go away and then have to come back again? That's a truck roll, right?
Yeah.
But say I jump in my truck and I can monitor it while I'm in my truck, and the customer's in the house and they hook it up. But they hook it up with a downstream preamp, a downstream house amp. That's 5 to 42, and I was trying to do 5 to 85.
And those are real issues we run into.
Yeah, we're running into them now. I mean, people are trying to experiment with OFDMA above 42 megahertz, and it turns out the initial ranging of OFDMA is BPSK or QPSK, maybe BPSK. It's so robust that even though the initial ranging is at, say, 60 megahertz, well into the roll-off of that filter, it's still coming online.
It comes online, but no data's going to flow, which is why we want to run these tests before we drop that modem off and walk away from that subscriber. Yes. We actually want to make sure the subscriber gets data. So I think we can do this. This is a new world. I think we have to look at how we're going to do these things differently. We absolutely can continue bringing customers online, and we're going to need to. I'm going to be getting a second service soon, and I want this modem. I don't want anyone coming in my house, but that's the way we're going to do it, and we're going to see other people doing the same things. Business has to continue. We can't just stop. We just have to think about better ways that we do the business. And I think we can absolutely solve these problems. I don't think this is going to be the last pandemic. Just as you said at the beginning, we just have to come up with better ways of handling it. So there's no need we have to go into people's houses every time. And we're going to do it. We're going to keep going.
Necessity is the mother of invention.
Yeah. Oh, and I think we're going to see a whole lot of inventions coming out of this one. So, all right. I think we covered it, my friend. Anything else you want to cover?
No. I think it was good. I think I might even have to go review this one myself just so I can summarize it.
Well, I would ask, are you traveling any place? Are you going to any shows? But I'm pretty sure we're going to be here.
I was supposed to speak at ANGA in Germany, and that's been...
Yeah, so ANGA is postponed until next year. I'm waiting to see if SCTE Expo.
How can you say postponed?
Yeah, it's canceled.
Exactly. If it's an annual thing, you can't postpone a year. So if you postpone, what happens to next year's conference? 2 in a row?
Exactly.
And then I was supposed to talk at Cisco Live, which is our big showcase event for Cisco in Las Vegas in June. and that's going to be all complimentary, no charge, but all online.
Yeah.
So it's all digital. And that's June 2nd, 3rd, I
That's
think.
why it's complimentary. It doesn't cost anything. You already
Generate
have
more traffic.
WebEx, man. You own WebEx.
Exactly.
All right. Well, hey, everyone, thanks for tuning in. Thanks for your questions and comments. We will have our next show, episode 58. So those of you at home, you have 56 episodes plus this one to catch up on. We'll have episode 58 on April 28th. We were going to do plant balancing this week, but John will talk plant balancing potentially next month, depending what's going on. John, thanks for your time today. We do our best to just keep bringing good content. So please click subscribe and click the like button on this episode if you liked it. And if you're listening to the podcast, please keep subscribing. Everyone, keep your distance, social distancing, stay healthy, and please keep tuning in. Thanks all. Bye-bye.
All right. Take care.
See y'all.